Okay, so I'll go over this one really quickly, okay? These are the constraints. Still frozen? Oh, sorry. These are the constraints. So these are the inequalities that we have to graph. So let's do that real quick, as quick as we can. So x greater than 0. So that means all the x values have to be greater than 0, okay, this way. Y values have to be less than 0. So that actually brings us down to this region here, right? Less than 0. 3y is greater than this negative 2x plus 3. You could do a table of values, or you could draw the corresponding equation of the line and isolate your y. So I would do this, divide everything by 3, so you get negative 2/3 x plus 1, okay? So that's your boundary line for this one, and so that's a plus 1 here as an intercept, and then you go down 2 and over 3. So 1, 2, go to negative 1, and over 3. 1, 2, 3. There's another point. It's an or equal to, so we'll draw that as a solid line. So there's number 1. There's your first line. Test 0, 0, okay? 0 equals 0 plus 1. Now, does that fit with what this sign is here? Is 0 greater than 1? No. So that means you have to shade above this line, okay? So we'll do the same thing for this one, y equals 2x minus 7. That's this line here. So we go to negative 7. That would be way down here, negative 7, and then a slope of 2. So I think that would go something like this. With your graph paper, you would have a little bit more accurate drawing. But we'll test 0, 0 again. 0, 0 minus 7. Does that fit? Is 0 greater than negative 7? Yes, 0 is greater than negative 7. So that means that this side is part of this. So we see this little tiny triangle here. And we actually got to this point yesterday, okay? So here's the tiny triangle. Okay? Now what we have to do is figure out this corner, and this corner of that feasible region. So if you notice, this first corner right here is the x-intercept for this first line that we drew. The x-intercept of this one. So what I have to do is I have to let y equal 0 to find the x-intercept. So if y is 0, I have this. Okay, negative 1 equals negative 2 over 3x times 3, that's negative 3 equals negative 2x. Divide by negative 2, I get 3 over 2 equals x, positive. So this is 3 over 2 comma 0. That's this point. Okay? Everybody got that? Is that good? That's how I get my first x-intercept. Now I want to focus on the other line, which is this one here. And the reason why I do the intercepts is because, remember, it was x, the x equals line here, right? So that's the upper boundary. Sorry, y equals line. That's this one. This forms the upper boundary there. So y equals negative 2x minus 7. 0 equals negative 2x minus 7. 7 equals negative 2x. X equals negative 7. No, sorry, give me a second here. Oh, this is positive, not negative. Come on, computer, over 2. So this point right here is 7 over 2, 0. Finally, you have to find this point right here. And again, if you draw this with a ruler on graph paper, you might be able to get this one fairly easily, I'm not sure. But how you do that is you let the two lines equal each other, just like we did in grade 10. So 3y equals negative 2x plus 3 is the first one. Y equals 2x minus 7 is the second one. So you can do substitution or elimination, right, to try and get rid of, to try and solve this. So if you do substitution, I'm going to put that value in for y in the first one. So it's going to look like this. This is stuff we haven't done for a while, so I get it. But this is how you do this. 6x minus 21 equals negative 2x plus 3. So So I'm going to add 2x to both sides. I'll get 8x. I'm going to add 21 to both sides. And I'm going to get 24. So x equals 3. So that means that this point has an x value of 3. And then what's the y value? Well, you put 3 into either one of these equations. Yep.
How did you get like the line, like the like one of the lines? Yeah, that one.
This one?
Yeah.
How to get that one? That's this one right here. So you have a y-intercept of -7. You have a slope of 2. You go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then. Well, all you need is 2 points. All you need is 2 points. You just connect the 2 points. So -7, I go up 2 over 1, up 2 over 1, up 2 over 1, just and then draw a line.
Why is it over 1?
Because the slope is 2, so that number 2 is 2 over 1. That's rise over run for slope. Okay? Okay, so then you put your 3 in, 2 times 3, so y equals 2 times 3 minus 7. That's going to be 6 minus 7, y equals -1. So this point is 3, -1. Okay? That's the stuff we haven't done for a while. That's the big part of number 2 there. Now, what we need to do is plug these points in. You have 2 options. You can rearrange your d function, or you can just plug the points in. It doesn't really matter. One of the ways that I taught you to do this yesterday in 6.6 was to solve for y here and find your intercept d. So if you solve for y, then we're going to get 3y equals 5x plus d, or y equals 5 over 3x plus 1/3 d. So this objective function now has a positive slope and it has a positive intercept. So the line, if you draw several lines with this slope through these points, okay, then again, you want to try and do your best 5 over 3 to do that appropriate slope. But now you're looking for the largest intercept here, okay? And this one is the largest intercept. So that means that this point right here, that point that line goes through, that point is the point that's going to maximize your objective function. Okay, because it says what's the maximum solution. So, so then you go d equals -5. What's the x value of this one? That's 3 over 2, or 1.5. And then plus 3 times 0. Okay, so d equals -7.5. That's going to be your maximum value there. So determine the maximum solution for this objective function. The maximum solution you're going to get is -7.5. And if you put the other points in, if you put this point in, the objective function, and this point in, you should get smaller numbers than this. Okay.